Hello and welcome to this video. We are going to learn how to find the modulus of a complex number. So let's say we have a complex number z is equal to 3 plus 4i. So how do we find the modulus of such a complex number? So the first thing that I want us to do is to represent this complex number on a plane. So we have the real axis and the imaginary axis. So this means that we're going to move 3 units on the real axis. So 1, 2, 3, and then 4 units on the imaginary axis. So let's have 1, 2, 3, 4. So our complex number is going to be mapped somewhere here. So when we talk about modulus of a complex number, we are actually talking about finding the length of this point from this point, the origin, to where we have mapped our complex number. So let's have that. So we have this distance from here to here as 3 units, and then from down here to up here is 4 units. So this means that we can find the length of this line using the Pythagoras formula, and that is what we're going to use to find the modulus of this complex number. So just go ahead and try to work out this length using the Pythagoras formula. So you're going to have 3 squared plus 4 squared, and then we find the square root, and this is going to be 9 plus 16, and this is going to be the root of 25, which is equal to 5. So that is the modulus of this complex number. Let's look at another example. Let's have 6, or z is equals to 6 minus 4i. So let's find the modulus of this complex number. So we can try to map this complex number on our axis here. We have the real axis and the imaginary axis. So we are going to move 6 units on the real axis. So 1, 2, 3, 4, 5, 6, and then we're going to move negative 4 units, or rather 4 units down the negative part. So we are not going to move upwards like we did for the other one. We're going to move downwards 4 units, the negative axis. So 1, 2, 3, 4. So our complex number is going to be mapped somewhere here. So finding the modulus of this complex number means getting the length of this line from the origin to where we have mapped our complex number. So we are still going to use the Pythagoras theorem to find the modulus of this complex number. So we moved 6 units, so the distance from here to here is 6 units, and then downwards we have moved 4 units. Okay, so finding the length of this line, we're going to use the Pythagoras theorem, that is 6 squared plus 4 squared, and then find the square root. So this is going to be 36 plus 16, and then find the square root. So this is going to be the root of 52. The root of 52, which is going to be 7.211 units. and that is the modulus of that complex number. So generally, what we do when finding the modulus of a complex number, you don't have to represent it on a plane like we have done, but you can still do it so that you make sure that you don't make any mistake. So you can just let's have z is equals to a plus bi. So that's the general formula of a complex number. So to find the modulus, we just take a squared and then plus b squared, and then you find the square root. So that is going to be the modulus of our complex number.